Hello and welcome back to the lecture on applied econometrics.
Hello and welcome back to the lecture on applied econometrics. We have been talking about instrumental variable, and in the previous lecture we spoke about endogeneity problem and how instrument can actually come to rescue any problem of endogeneity. Now we were careful about the fact that an instrument could be good, bad or a weak instrument, and we need to be very choosy about an instrumental variable if we are really planning to use an instrumental variable in a research. And in a given context of a research, an instrument could either be good or bad, or it could be a weak instrument. Now we need to be able to identify if an instrument is good or bad or weak in a particular research. And we will see there are certain ways. Of course, we have some idea by now, but we will outline the theoretical framework to identify if an instrument is good, bad, or a weak instrument. Okay, so let's try to understand graphically the relationship between x, y, z, and the error term u. So if I have my x here, and let's say I have my y here, and I have my error term u here, and let's say I have a z instrument which is here. So I'll try to identify the relationships which are desired, which are not desired. Now I want, let me use different colors to notify that. So I want x and y to have strong relationship. Okay, so I'm using a green color, and let's say I do not want, I do not want any relationship between x and u. So I'm basically marking it as red, but it is present if I have endogeneity. So I want to actually avoid this. Now I want to use an instrument. So when I want to use an instrument, so there should be strong relationship between this z and x. There should be a strong relationship between z and x when I'm using them as an instrument. Now what I do not want any relationship to exist between z and u. Now I use a dotted line because this relationship does not exist. Okay, so I do not want. So it is a dotted line, but it's red because that is undesired. Okay. Now, so far as the relationship between y and z is concerned, so I know that z is going to influence y, but through x. It is the entire effect of z is to be channelized through x. That is the desired condition. So essentially, let me draw it. So I can draw something like this. It's a blue line, so that it basically indicates that there will be correlation, but that effect will be channelized through this. Okay, essentially that is going to be channelized through this. All right. So with this, we sort of get the criteria. The criteria we have for a good instrument is that covariance of x and z should not be zero. That is, this relationship has to be strong, and covariance of z and u, that should be equal to 0. There should not be any relationship between u and z. And the third criteria that you said is that z should not be in the regression equation on its own right. Okay, so we'll write z not in regression on its own, on its own, right. Now the first criteria here, when I say that x and z has to be strongly correlated, so this is basically a criteria for relevance. And the second criteria is basically the criteria of exogenousness. So z is exogenous, and also it is exclusivity also, because the effect of z is not channelized through u, but it is channelized through x only. So it is exclusivity also, you can say. Okay. Now let us write down the expression for the instrumental variable. So let's say beta to iv here is going to be covariance of yz divided by covariance of xz. All right. Now let's say the relationship between covariance yz is very weak, and let me actually write down the very simple equation for instrumental variable. Let's say my y, let me use a different color, my y is equal to beta x plus some error term u, and my x is equal to some alpha z plus some another error, some gamma. Okay, now here z is the instrument and x is the independent variable that explains y. Okay, so in this context, in this equation context, I can write this beta to iv, or which is basically an estimate of beta, is basically this. Now, if I expand this, let me actually expand this covariance xz. So covariance xz is going to be, if I substitute x with this, alpha z gamma comma z. So what I'll get is basically alpha sigma z square, right? Now, if this alpha term is equal to 0, so then what I'm going to get is that the covariance, this term, if I expand it, I will, this covariance between gamma and z, that is going to be 0. So essentially, I'm going to have only this term, and if my alpha coefficient is 0, so it is going to give me a 0. So what I'm going to have in the denominator is 0. Okay. So if I have my denominator 0, so B2 IV is going to be undefined. Okay. So that is something I do not want. Even if I have my B2 IV is actually very small, so that is going to give me, even if this covariance xz is going to be very small, so that is going to give me a very large value of B2 IV, so which essentially would mean I am going to get a large variation of B2 IV, which I do not want essentially. So this is the problem when I have my, the problem when I have this relationship between x and z weak. So this is an example of weak IV. So we do not want any weak IV in the regression if I'm really going to use an IV. So I do not want a weak IV. And one example of weak IV could be, so one particular research that is actually a very famous research by Kruger and Angrist. So these two were and many other econometricians, but Angrist has a lot of contribution. Kruger also has a lot of contribution in so far as IV regression is concerned. So they published a paper in 1991 where they actually tried to estimate the effect of schooling on earning, but only this time they thought that the education or schooling is an endogenous variable. That's not an exogenous variable that we have been doing all throughout. So if earnings is a function, let's say alpha plus alpha 1 plus alpha 2 education and many other variable, but that is how it is related. But if this education is not exogenous, so they said they are endogenous variable. So what they did, they actually took an instrument, and the instrument is the year of birth or quarter of birth rather. So the idea was that depending on the quarter of birth, so people will have, the students will have, or the children will have a specific age to, cutoff age to join a particular class. So essentially they will have different age group differences, like people who are born in the first quarter, second quarter, third quarter. So that way they wanted to see if they can actually find the true effect of education. Unfortunately, so that was not considered to be a very strong IV, because that quarter of birth explains very tiny proportion of the variation of schooling. So that was a research that was done later on by, the name is Baker, Regina Baker, Ziegler, and I think, so that was in 1995 paper. So this paper actually sort of brought out the fact that the IV they have used, that's a weak IV, because the quarter of birth actually explains very little in the variation of schooling. So that is an example of weak IV. So perhaps we will try to avoid the cases of weak IV. Now I'll talk about a bad IV. A bad IV is something where the relationship between covariance of Z and U is not equal to 0. Essentially, if this relationship is this part of relationship, that is actually, there is some sort of relationship. So then that is actually a bad IV. So we will again try to avoid that. I will just give you an example of bad IV. Let's say, just like the previous example, education. We know that education is a endogenous variable, and let's say I have this equation again, y is equal to alpha 1 plus alpha 2 education, and let's say some other variable, and there is some u term. Now I know that education is an endogenous variable. Instead of quarter of birth, I have chosen, let's say, parental education or parental income. Let's say parental income, parental income. Now I know if my parents are rich, so they're going to send me to good schools. They're going to. Now parental income may appear to be a good instrument because parental income has a strong relationship with education. So I can write covariance of, let's say, parental income and education is not equal to 0. So the first criteria is met and I can consider that this is to be a good proxy. But there's a problem here. The problem is parental income is just not related with my education, but there are so many other factors that parental income is related with. And let's say it is parental education. Okay, so parental income is basically an outcome of parental education. So parental education and parental income are related. And then what is happening is the fact that I am not including parental education, so parental education is getting into the error term, right? At the same time, parental education is something that is influencing my education, because if my parents are educated, I am likely to be more educated because they're going to take care of my schooling, my home education, and other aspects of my learning. So because of that, because parental education is now into the error term and this is actually influencing my education, so what is going to happen is exactly what we are afraid of, the relationship. There is a correlation between error term and the education, which I actually wanted to avoid because I wanted to avoid the endogeneity problem, right? So then the equation, the condition that covariance of education and error term should be equal to 0, or covariance of here if I use my proxy, so parental income. So this is not equal to 0, of course, and of course this is not equal to 0 because of the fact that covariance of parental income and the error term is not is equal to 0. Okay, so my condition 1 is fine, but my condition 2 is actually violated. This is violated, right? So then it is a bad proxy. And you can think of what if I actually take parental education instead of parental income. You can actually think of that, right? Now actually let's think about that. So if I think parental education instead of parental income, well, so parental education is of course influencing my education, so that I have seen. Now whether that will actually solve the bad IV problem is essentially it will not solve the bad IV problem, because parental education is related with other factors and like parental income. So parental education is influencing parental income here. So let me write down. Let me so my IV here. Let me write down. Let's say parental education. Now parental education is now going to be related with parental income, right? P income. Now, because I'm not considering parental income into this equation, so what is happening is that the parental income is influencing the error term, right? It is influencing the error term. Now, parental income is another variable that is also influencing my education, because my parents can afford my education, so they can send me to private schools, they can send me to other, teachings and good, they can provide me good books and everything. So that is basically influence my education, right? So in the same way, like we have a problem with parental income as my instrument, I can have the same problem with parental education as my, if I consider that as an instrumental variable. Okay, so these are the examples of bad IV. Now we can think of good IV. Whereas when it comes to good IV, we essentially need to identify or ensure that these three properties of a good IV are satisfied. These three properties are satisfied. Now, one example of a good IV could be this 1947 reform that was brought in UK when the minimum age of schooling was legislated. Now, so far this mathematical and theoretical knowledge on IV is fine, but this is not enough to actually do a research with a good IV. You actually need to find out a good IV in the first place, and which IV could be a good IV. To sort of get an intuition behind it, you need to do a lot of you need to build a lot of institutional knowledge. You need to do a lot of reading, a lot of talking, and actually visiting sites and so forth.
to actually identify what intervention was brought and what is possibly the impact of those interventions. And in a word, you can say finding a good IV is basically doing shoe leather research. You need to do a lot of shoe leather research to actually find out a good IV. Okay. So with this, we will end this lecture here. And in the next lecture, we are going to talk about a couple of more properties of an IV regressor that we need to satisfy in order to sort of have a good IV. Thank you.